Hi, welcome to Project Geospatial. I'm Adam Simmons here with another episode here at the 2021 GEOINT Symposium in St. Louis, Missouri. I'm at the Kleos booth with Vinny Furia, right? I get that right?
You did.
Awesome. So Vinny, tell us a little bit about yourself and we'll dive right into Kleos.
That sounds great. As you said, I'm Vinny Furia. I'm the CTO here at Kleos. I've been with the company just about 7 months now, and it's been a very exciting time for the company. We're going through a lot of growth. Our first 4 satellites launched back in November of 2020, and we had 4 more launch here in June. So for us, it's been a great adventure, a lot going on, and we're really excited to start getting products and data rolling to our customers.
Well, that's a huge deal because 2 years ago when we started talking to you, everything was, well, aspirational in a lot of ways, right? You had a lot of issues with launches, but you finally got the birds up in the air and see what they can do.
Yeah, definitely. COVID obviously slowed us down a lot with the launch opportunities drying up for a while there. But now the satellites are up there. We're starting to do our calibration, our early orbit checkout, seeing what our data can produce. And we're very excited here because we have gotten good results so far. We're able to do our main geolocation product that involves the 4 satellites that are in each of our clusters. Finding transmitters on the ground, geolocating them, and providing those points to customers.
So just to back up for a second,
Yeah.
for those who don't know much about Kleos here, you're not a traditional imagery satellite, you're a radio frequency event.
Correct. Our focus is on getting that RF data. Specifically, we're trying to track down where those transmitters are. And to accomplish that, we fly these clusters of 4 satellites. They're in a pretty tight formation. They're only a few hundred meters apart. And in this formation, they're able to, by measuring the difference of the time arrival of the signals, we're able to calculate where transmitters are on the Earth with pretty high degree of accuracy at down to 300 or so meters.
Down to 300 meters, that's amazing. So what kind of coverage on the Earth do you have right now?
So our first cluster launched in a 37-degree orbit. So that sees basically everything up to 40, 45 degrees north and south. Our second cluster, though, went into a polar orbit. So those satellites can see everywhere on the Earth. So we're able to get results from anywhere on the Earth that our customers are interested in.
Okay, that's amazing. So how big are these satellites? Do you build them yourself?
We contract out the building of the satellites. We use a standard 6U size satellite.
Okay.
The nice thing about these cube satellites is they're very quick to develop. So even the difference between our first and second cluster, we're able to do probably 3 times, maybe 4 times the data collection just in a year of development time. So our next cluster that's going up, hopefully early next year, that one's going to increase our capabilities again by adding X-band detection to our current VHF detection capabilities. And over time, those capabilities are just going to continue to increase.
So you're taking advantage of the, we'll call it the small satellite, just the form factor to rapidly innovate and release your new generation satellites fairly rapidly. And that's a huge, big game changer.
Exactly. It's a common denominator in ththose of us who use this CubeSat standard. It gives us the ability to quickly iterate on designs. The costs are pretty low for both the development of the hardware and launch costs. So we're able to make pretty big leaps in a very short time. Our typical development time for a new satellite is about 9 months. So what kind of use cases can you talk about for some of your satellites, some of your data, and who uses it right now? Yeah, so our primary use case right now is in the maritime domain. We're trying to look for those ships that are currently running pretty dark.
Okay.
They're targets that are hard to find. Think illegal fishing, illegal offloading, or bunking. Those sorts of use cases are where our technology shines, because a lot of these, while they may turn off their, let's say, their AIS transmitter, they're still using walkies to communicate across the ship or between ships. They're transmitting their radar. They don't want to run into anything. So while these ships are trying to run quiet, we're still able to detect them and find these. And our data combined with other data sources can provide a lot of valuable intelligence of where these ships are, what they're doing, and hopefully clean up our oceans a little bit.
So let's talk about the RF industry for a second here, and it's grown in significant years, right? So what do you think about the growth, and what does it mean for Kleos?
Well, definitely RF, I think, is a huge untapped. When people think of space, they usually think of imagery or communications, but the availability of these RF technologies on orbit is just going to be a huge unlocker for not just intelligence, but I think even for a lot of commercial entities. It's maybe the difference between seeing and hearing. Sure, you can get a lot of information with your eyes, but if you add into that information that you collect with your ears, that synthesis adds a lot more. So I think imagery or RF data by themselves, they're great products, but when you combine all that into a combined data set, you unlock a lot of capabilities for intelligence and Earth observation in general.
Now, I believe you had a big announcement recently, did you not?
A couple of them.
Okay.
I'm not sure which ones you're referring to, but
well, you can mention as many as you like. Let's just say going back recently.
Okay. The big thing is we did release a white paper that describes our technology. What we've been doing over the last several months since our first satellites got on orbit is a lot of testing and calibration. So in the side of this white paper, we actually show some of the results of what we can do with these satellites.
Yeah.
So it gives a great example of our RF geolocation capabilities, what that data looks like, and we share how we collect that data and how we tell you the background of what our accuracy means. The hope is that different analysts can read this and understand what the quality of our data is, and hopefully trust it in order to use it in their future work.
Awesome. So as we're wrapping up here, do you have anything you'd like to relay to our audience about Kleos or the RF industry that can get them inspired by what you're doing here today?
Well, I have to say we're very excited. The industry, specifically around RF intelligence data, is growing a huge amount. I mean, I think you can see that today, not just with us, but all the companies that are here today. The capabilities are growing extremely fast. There's a lot exciting going on in this field. I have to say, I'm just really excited to be part of it. So can't wait to actually see the other videos you've worked on today, because I'm sure you've talked to a lot of very exciting companies with a lot going on.
Absolutely. Well, thank you for joining us. Once again, this is Adam Simmons here with Kleos Vinny, and we'll talk to you everybody next time.